Go ahead, sorry. So we're on the horizontal.
Do we need to do horizontal, or do we realize that one, because we could do the vertical?
We're pretty sure about that. Let's talk about the diagonal.
Yeah, that one's really got me wrong.
Yeah.
Oh, sorry. I'm not doing my job. Ashley.
Oh,
Which one?
Davidson.
and I'm sitting there going, what? Oh, I think that if a line is a straight line diagonal, that your x and y would increase by 1 each time, or decrease by 1.
Only
Consistently.
Consistently,
Consistently.
but not necessarily one.
Right.
Well, you said whole numbers, so.
Or yes, the line would pass through points that increase or decrease consistently by 1, or at regular interval. Is that,
Yeah, and in this case, whole numbers may not be the best example
Yeah.
because any numbers, they would increase at a consistent rate.
Right.
Yes.
What do you mean by consistent? I don't know that.
each time, when it increases on the x, it's also going to, if it's increasing on the x, and it is increasing on the y, then the amount of, that it's increasing will be the same for the x and the y. They will be consistent and follow each other. Or,
Do you mean that x, the increase in x has to equal the increase in y?
yes.
Always? For all
Well-
diagonal lines?
If they will increase or decrease. I'm getting there. It'll increase or decrease on a, I keep going back to consistent. So an example would be, if it's increasing by 1 on the x, then it's going to increase by 1 on the y. Or alternatively, if it's increasing each time, the next step will be the same. Yeah. Will be the same amount as the step before. Repeated addition.
That's true, but that doesn't answer the question about, does the increase in the x always of the same as the increase in the y?
No, it doesn't.
Only if it has a vote.
No, you can increase on the x, so each time the x increases by a certain, if it is increasing by a certain amount, if it is. And if the y is decreasing by a certain amount, that's okay too. But each step in the function is going to be consistent with the direction that it's going. Repeated, like a repeated addition or subtraction. It's, if you have a increase 2 plus 2 plus 2, and even a minus 2, minus 2. If you're going to do minus 2, the next step is going to be a minus 2. And the next step will be a minus 2. Or plus 1, the next step is going to be a plus 1.
Can we get to Melissa, are you gonna clarify that?
I was just gonna ask, would you say that it was changing at a constant rate of change?
Yes. Yes. Constant and consistent rate of change. I like it.
Nice vocabulary, but didn't answer Rose's question. Does the x,
So change
do the x and the y have to change by the same amount each time?
Oh, no, it depends on,
She answered that.
that's where the angle, no, it doesn't have to be. Well,
Because
hold
every
on.
example you gave, they did.
Yes, because it makes a pretty picture in my head.
Okay, so can you make a not so pretty picture in your head?
That's accurate?
Well, yes, you can go increase by 3 and just by 1, but it is, then it'll still create a straight line.
Okay,
Right, yes, it doesn't have to be 3 and 3, or even 3 and negative 3. It can be 5 and 1,
okay.
but the rate has to be
Constant rate of change.
for the y-axis, whatever that is, and it has to be a constant rate of change for the x-axis, whatever that is, and they could be different numbers.
So Melissa, you had your hand up. Any last comment?
No, that's what I was gonna say.
Okay, so can I just make one comment? This was all done abstractly, which is very difficult. Russell and I were not able to converse before this, or we could have had like grid paper or something for you to illustrate this on. So I apologize for that, but that's my fault because, you know, I'm in Houston and I'm not right here. But y'all are adults, so y'all have this abstract ability, much more than the children do. So I would not do this abstractly with students at any grade level at all, okay? So I do apologize for the abstractness of all of this. We really needed pictorial. Of course, Russell is extremely abstract.
Well, can I not apologize for being crazily abstract?
You do not have to
And to
apologize.
see the problem it caused, putting that into words was immensely difficult. What I might think is a simple question. It's obvious, because arguing on the answer, and I've been through years and years and years of training, and then the poor student is asked that, and then I didn't have the vocabulary to put down the words. But when you said, they make pretty pictures in my head, I'm like, yes, that's exactly why we have pictures. That's why we would spend the time drawing pictures, to see what we mean. So that whenever we use the word, picture is attached to something physical that we've done. Either we've drawn a picture, or we've moved it, we've done it, and that kind of thing. She's got up there concrete, pictorial, abstract. Just never forget and put the other right first. 'Cause that's, I've described in my class things that are in my head, and I do it like this. So what do I look like in them? Somebody doing this. See what's in my
Actually, it was
head.
pretty much doing that.
You live and learn. Okay. How do you think 3 dimensions would be represented? That's easy.
Easy for Brandon.
Physicists have, I'm gonna show you one. Physicists have a gang signal, a little symbol that we use. You're walking past these physics geeks and you wanna get through safely. You go, hey. Right hand. Right-handed coordinate system. Hey. So anyway, back to the start. You can ask the question now if somebody.
Yeah, it's all Brandon.
Brandon, it's all you. He's like, I know my name.
Are we referring to like a three-dimensional shape or?
We're still talking about the coordinate plane.
The coordinate system that's set up, a reference frame, so it would be 3 dimensions rather than 2 or 1.
I knew the first 3 questions.
Wait a second, the reference frame itself, it would have 3 dimensions.
I say I'm just confused about the question, like, I would graph things that have an X and a Y. We've seen some things with X, Y, and Z before.
We're talking, the basic idea that we're getting through all this right now is position, and describing where things are by having either a number on a number line, or an ordered pair in a plane. Now we're just asking you for 3 dimensions, just 3.
Brandon, what did you just say? You graph things on what?
Yeah.
X and Y, and what was the other one?
Z?
Oh.
3 coordinates,
Correct.
3 dimensions. We go together. Hey.
That's why I Z. Is that?
Yeah, it just took a while before you finally said X, Y, Z.
What does that Z represent? I don't know.
And I really don't know.
What? So your X would represent what?
Location, on the X axis.
Okay, but on a three-dimensional figure.
This is a coordinate plane, flat surface, 2 dimensions. It wouldn't that way. It wouldn't. How could you make it 3 dimensions?
thinking.
I'm doing fine.
I'm trying to visualize in my mind. May I help? Where, are we allowed to, we can only
Yeah,
ask questions?
Yeah,
Is that-
they're the mean teachers in the back.
If you had, so if you had a two-dimensional picture, the X and Y would represent what? If you had a square, the X and Y would represent what? Thank you. So it would represent the length and the width. So what would your Z represent? That would be my height. So what quadrant does it have to follow? Can it be in quadrant 4?
And what,
The three-dimensional.
not on a two-dimensional, short piece of land.
No, on a three-dimensional, if you had,
The rules that we would have for all the quadrants wouldn't be different in a three-dimensional system.
well, you can't have any negative.
Brandon, the
I
X
can't hear.
represents the what? When we say X, you said X, Y, Z, the X, you meant, what do you mean by X?
On graph, it would be, the
Loudly,
on the
please.
X- On the X coordinate, on the X axis,
On the X axis, okay, so the Y would represent what?
on the Y.
Okay, and then the Z would represent,
I'm tired of playing this stuff.
so you're saying the whole plane itself, for all of infinity, would be the Z? Why did you switch from earlier? You named the Z axis itself, what would make you switch that? What happened that made you go from the Z being its own axis? I don't know what this one.
Not being sure,
Huh?
not being sure what I'm being asked.
Okay, so,
Can I help build it and you can complete it?
Okay.
Let's imagine that I start with making I want to locate the position of something.
Okay.
I start with a reference point. I just say, call that the origin. Someplace. That's not where the thing is. I don't know where the thing is. I'll figure that out later. So I'm going to pick a spot to call 0. And then I'm going to make an axis, a number line. It's got directions, pluses and minuses. So they're labeled along there. And that way, at least I'll know somewhere along that line where it's located. And I need to draw another axis to describe where it is. Well, it's perpendicular to the first one.
Create another axis.
Yeah, can you create another axis is the question.
Yes.
Where would it be?
Relative position to the origin, what would it do?
Well, if you're gonna draw another line, it's perpendicular.
Perpendicular to both the X and the Y.
Sounds like the next step.
I don't know what to do, I'm sorry. How would I do this?
How would you draw a dimensional shape?
Guys, we have to talk out loud so the rest of us can hear.
And I would not draw a three-dimensional shape on a three-dimensional shape.
That's what I'm saying.
Oh, okay.
He's trying to do it, and I'm saying,
Yeah.
how would you do that?
Some people would draw perspective. I did that when I was a little kid all the time. I could draw an
How could you make something perpendicular to this, to your notepad? How could you make something perpendicular to that, which is a 2D?
There you go.
Bam.
I don't know how to say that.
Oh, of course. That's why I started this out with the gang signal, hey, third one. It's very hard to describe that in words.
Okay.
So just for my clarification, so on the notepad,
I can do it.
where, which, George, would you consider the x-axis? Either
Like-
Melissa or Brandon.
Okay, so when he drew it on here, he drew his X, then his Y.
My wife would do this,
So the x and y are drawn on there, that's what I was
Yes.
missing, I couldn't see that.
Yeah, because he drew it over there, but I just was giving him
Yeah,
a concrete example of it.
thank you. So then the z
Yes.
would be the
Use it this
pin.
way when I bring it up.
All right, thank you, I just couldn't see what was on the paper.
Passing through the origin,
I don't know how
and
to
if you
do
measure the
it.
angle
Say.
between the axes, they're all 90 degrees. And we're not gonna talk four dimensional, you're not gonna try to draw it.
So if we're looking at the corner of the room here, if we're looking at the corner of the room,
That's the,
where could the x-axis be?
Would you like that?
No, I don't think you can do that.
Okay.
Where would the x-axis be? If that's the origin, where he is. We could consider this
This way,
wall
right?
the x-axis, and
Not the whole
then,
wall, just the intersection.
ceiling.
That
well,
line.
the edge of that, yeah, I'm
Right.
sorry, sloppy language.
Yeah.
The edge of the wall there, and then the y-axis, Brandon, which one would you consider?
The corner or
Which edge?
Okay, this is the x-axis.
You just did it with your
There,
finger.
that edge, can anybody see where I'm marking?
Right.
Yeah,
So
so
what-
say
that's what
what
I'm
you just
saying.
did with your hand.
oh, just watch my hand.
Okay,
This
so
one here, no,
the
that
edge
line.
going down is the y.
Right.
Okay, so then what would this one be? Because the x is going vertical.
Right, that would be
I mean, the
my
y is going vertical,
other
Which is,
axis, which one?
which we
Would be my
call
Z.
the z. Okay. Thank you.
You got this.
There's
there
the,
you go.
there's the corner.
So, all right. That's why we do this, is the struggling here
we need to
is the
wipe
thing
this.
that, if you remember, the students
Yeah.
have that same problem. And it struck me a long time ago. Somebody asked a little kid, why did you do this? And I realized the kid doesn't have the words to say it. They go, "Oh." They just did it, because they don't have the words to describe it. And so trying to force words out of somebody in a picture, worth 1,000 words, might say, oh, now I see what you're talking about, and then they can see if they can put it in words.
Hence manipulatives and pictorial,
Yeah. And word problems.
and word problems.
Word problems
And
are
tied to
problems with
manipulatives
words.
and pictorial.
Real problems. Okay. Whew. So, is that enough of that? That. What do you think? We didn't do scale factor.
We did not do scale factor.
And the difference between distance and displacement? One's the entire distance of
Distance
the
and-
path. The other one's just from this place to that place, straight line, but from one place to another.
Which is not the same in mathematics.
I wanted to-
Mathematicians
yeah.
call displacement distance,
Distance.
and we don't worry about y'all's
Yes,
distance.
exactly.
The crooked path, we don't worry about that.
Yeah, we get to be crooked, but they can't.
Yeah. You're linear.
I have a question. Where would that, where would that vocabulary come in? What grade level is displacement in math?
We don't use displacement at all.
Okay, and so
You mean
it's,
the word or the term, or the meaning of the word?
no, the word,
We don't use it.
okay. And so displacement in science is when they're measuring volume, and I don't remember what grade level that is.
It's on that one.
No, fourth, it's taken that.
But she asked for science.
Oh, for
It's either
science.
sixth or eight, it is.
Science,
no, we do
It
it in.
depends, are you talking math just scientific, like in science class volume?
Yeah.
Measuring
Because
the
then
volume.
Just with a
no,
graduated
where
cylinder.
they're measuring they're measuring volume by displacement.
Oh, yeah, 50.
Which physics people use displacement also in that term, that way, but also in the way of saying specifically from here to there.
But in science, I don't see that, I don't see displacement.
It's gonna show up sometime.
Well, I'm thinking maybe high school physics.
She said I
It's only in
It's
IPC.
in
She looked it
IPC.
up on the standards.
She looked it
Okay.
up. Thank you. So so this is a high school vocabulary word displacement is.
But in the sixth grade peaks, that address position,
Mhm.
would that term?
It's not in your TEKS, and I don't know where it is in the standards, but Alexis, I'm sure, can look that up for us. Look it up in the framework.
It's in physics also, high school physics.
Yeah, Yeah, that would make sense, but I'm trying to think if it's, so it's in IPC, so it's not till high school. And I bet it's not in middle school
No, it's
in
not.
the standards, not TEKS, standards. I know it's not in the TEKS. Okay, we'll find out and report later.
Scale factor, you can use it later if it comes up. Constant of proportionality.
We can also do that later when we talk about scale factor, unless you want to talk about it now.
Well, you know, that was exactly that thing about the diagonal line.
So, yeah, so going back to Ashley's examples, I don't know how you were doing it, okay? And then Melissa said a constant rate of change. So if the Y is changing 2 units and the X is changing 3 units every single time, that is a scale factor. It's also a constant of proportionality.
Two of these for 3 of those.
Right.
And distance, do you want to do the distance formula or do you don't know?
Do we have to know that right now, or?
Not really.
Okay, then let's not do that right now.
So that's what they do, all that kind of stuff. But see, I left this in because you were the math person, that's
Yeah.
why it's the longer one. And then, point of reference, and then we're going to do, do that. I don't even know what it is.
Which one?
Oh, when an object changes position, we say that it moves. So if the object moves, like Russell, move, we change position. And that lets us, let's just do that. Say that it's moved, even if we didn't see it move. Those little rocks that they have that go across the desert, you know, the little crawling rocks or whatever they call it. There's some what? On Mars. She says there's something on Mars. You weren't thinking about it. Okay. What do you think? Oh yeah, identify points of reference. Here's the thing. Why does it matter? What do you think? I'm just trying to catch you up. And so for those of you that remember doing this, we talked about the taxi driver and whether they take the long way around to charge you for the distance when the displacement was so short. And I want to do, what do you think, this one? I know where I'm trying to get to.
You know, about half of this room were not in here when, yeah, so back up to question 1 and let's just kind of toss it around.
That one?
Yes. So, and please remember not to shout out, especially if you were here then. Okay.
Man in
So,
tan jacket, the woman in the yellow coat. Okay.
he did draw Tim's name, so
That's convenient.
he drew it and handed it to me.
Bam, take it out.
So read the question to us, Tim, and then, let me read it because of your voice. Okay, you are the man with the tan jacket. With the woman in the yellow coat as a point of reference, are you moving? Think about it without talking at first, and then Tim is going to explain his conclusion. Are you ready?
In this instance, no, you are not moving because your point of reference is not moving. It's always the same distance from you.
Okay, somebody want to rephrase that? Candace, you want to rephrase that?
Okay, Tim, what did you say, what you said?
I said, in this instance, from the point of reference, my point of reference is not moving, therefore I won't be moving because it would always be the same distance away. My point of reference is the same distance away.
I would say that, if I'm the man in the tan jacket, I'm looking at the back of the woman in the yellow coat, I'm looking at her back. And so, in reference to me looking at her back, I'm not changing position.
Okay. Let's get one more. Brenda,
Restate what he said.
in your own words.
So, since the distance between the man in the tan jacket and the woman in the yellow jacket is stationary, he is not moving.
Anyone add anything? You agree, disagree?
But they're riding a bicycle.
That doesn't say that.
Can you say that they're moving at a constant rate, therefore they're equidistant at all times?
That's a Russell question.
What's equidistance?
I'm sorry?
I said, what's equal distance?
The distance between the man in the tan coat and the woman in the yellow jacket.
Okay, so what I'm talking about is clarity of language. And when we're in the classroom, we're seeing a lot of pronouns used. We're seeing incomplete definitions, if you would, or in this case, lack of clarity of, the question that I just asked.
Sloppy language. yes.
It's that old sloppy language, and you are required to videotape yourself if you want to get paid this semester. That is a requirement,
Does that
because
apply to me?
it-
I hope not.
you're already being videotaped. Because it is only when we videotape and we view ourselves in tape are we going to see what we're doing or not doing that adds clarity or confusion to our students' understanding. And too oftentimes, we teachers think, well, it's the student's fault they're not understanding. I told them.
So what did you, where was the sloppy language? And
What
what
did
she
you say
stated?
exactly, Pam?
I didn't think they're
I said that
equidistant.
they are
Between what?
moving,
Equidistance
they are
between what?
moving at a constant rate, therefore they stay equidistant to each other.
So
No,
they,
She said
no.
they,
She didn't say equidistance to what? That was what my
they
question
were
was.
just, they.
What was
Oh, I see.
equidistance?
Those
Yeah.
pronouns will get you every time.
It was equidistant, or they were equidistant.
Yeah, I think I said they.
Oh, I thought you were
Yeah.
saying the word equidistance, I'm like, okay.
Well, no,
What is-
equidistance was not wrong, it was
what
equidistance
is-
between what? Yeah, and if you, the ELL recommendations are just good practice for everybody.
Even me and Dr. West, I catch myself saying things in an imprecise way all the time, and I know Dr. West catches me because she tells me. And I catch her as well.
It's just,
You know-
it's a natural behavior, but as a
You
teacher.
know what you're thinking,
Mhm.
it just doesn't come out of your mouth. It's correctly said. There you go. So we agree that if the woman is the point of reference, the man is not moving. Yes, no?
Yes.
Thumbs up? Okay. Go ahead, you have a question?
I'm debating whether to bring this up or not.
The answer is no, because we're gonna take a potty break.
So, the white community, when they have is actually moving, but I suppose that you're just listening to it's like if you have blind spots.
They changed the teams, right? Even though they make a big deal about it.
And I see it taught before.
So what is our radius? Right.
that had obviously, in sixth grade, that changed, so, well, teenage circumference. They didn't know purpose. It had, because it had moved out of six.
Yeah.
They don't know that in elementary.
Right, so you can't just review with them, you have
Exactly.
to do a whole another lesson, a whole new
Yes,
lesson.
yes. And, I guess that's one of the things where, I really, I just, with my hair, it did like be some measurements. Because I couldn't just say, because that's one of those circumferences, they had no.
I was.
Oh, yeah, I tried that in my class.
So that's one of the things I've really lost. Is that 3 years ago, we taught that in sixth. They only had to know, like, I think the head, the heart. But yes. I don't know if it was taken out or if it was just moved.
Just moves.
No, because like when I brought it up, I was like, nope, they have no idea. I can just jump on the conference. Exactly. Without them knowing the parts.
Yeah.
It definitely extended. We had a whole, concrete lab on it.
It feels like my understanding was if your takes are not similar, but now I'm hearing your sixth grade takes are all got, so everything's kind of got shifted to seventh grade. I'm just
Think about it, 1 year. She said kids going to six. Going to six. That year they got moved down, and we missed.
a whole chunk of information, right?
That's like about 3 years. Because right before they did, like I said, they didn't have circles. So, it wasn't in sixth anymore. Strange, right? 3 year, third year.
You're at that, yeah.
Or what was it? Where,
No, wait, Paula, how are you doing?
I have one more question.
Oh,
Because that took our students.
I might leave.
Right.
Like I said,
But she is
how much
hammering.
So what's changed?
But how, she can't carry.
They are.
From like,
Well, I know, that's pretty big thing here.
I'm sorry.
No, I know what you mean. It's how they're going, she's doing
Yes, is
Oh,
so
I'm hoping it becomes a fruition. I just went to a training.
literal, like,
Right.
where does my formula have that L for range, so they're, but it's like everything, all the
So
time.
even in school governance.
So like you said, that's how those terms only really apply.
Just my board president had went along with these other.
Or any other shape, like you said, so they're trying to make it general. But
The whole board is there in the improvement requirements, and we went to the exactly how we got to go. because-
everything has to be,
So I think you just slid us in because we wanted to come, and
to make it more
we really shouldn't have been there because it's supposed to be the whole board and the superintendent.
I don't know what that is.
Just,
As we learn, I know about second grade last year, I was teaching basic height.
Yeah,
So they're learning, the length of
somewhere.
this rectangle is,
Some of
so they're
the
using the term and all, so make it to seven. So
So
I'm just trying to put it together, and it's, oh, it's a big
Trying to
thing.
figure out where they're at.
Length and width, so trying to
my husband,
tie those two
Figure
terms
out
together.
where they at.
I watched him for 35 years. This guy is as good as he was. In fact, one time
So
I
did you
was
stay in the same school, or did they shift you, or
No,
did you go to?
Yeah.
Actually, just teachers.
We're trying to get it, we're trying to get it.
Because I was teaching, I taught fifth and last year I had.
Yep.
So,
I know.
I was talking, working out though, yeah, I couldn't get working out, so I'm like, I'm not gonna do these things. So
I will go with you
and
to
the
the
section,
when you want to
let me
go.
know.
We gotta call each other.
Oh, yeah, that's a.
like to do middle Saturday or Sunday. Oh my God. I don't, okay, I'm not an elementary person either. So at a different pace. So I really like to teach homeschool because I didn't have to figure out what they didn't know. It was like everything, like there was so much they didn't already know, and there was like a good portion of what they knew. So it didn't feel like I was teaching them what plants for them. And then you know, group this. So like college, I mean, I don't want to obviously teach it, but for the most part, I already know most of those teams, you know what I mean? And then what you don't know, I'm cleaning up. Yeah, great, yeah.
Is that more soft, is that wide?
Biology, yeah, that's what I would think. Yeah. Because there's a lot of things that they know. There's like a little bit of things that they know, and a lot that they know. Like they know the basics. Seventh grade, they had a little bit of it. But they also, in seventh grade, they also had physics. And then they put top photos of what like they don't but then like fine tuning
The one in Margot is like right in the middle of the branch.
Oh, yeah. Right. It was strange just watching it change because I have just like this one. I've been just watching geared differently for everyone at that age. And it's so strange because they're coming into school and they all have that different activities. They're on different tracks. Now they have to know like their routine like a few different ages and put on that track and they get into high school and they got it, but they have to just have to because they're in high school. A year ago, now they have to be on track. It's not okay. If I'm not going to speak and it's there, then I don't have to know this. Yeah, and I hear it so different now. I'm serious. Right, because they don't try to do that now. Now they just, I can't figure out and I think it's because it's like someone's already, I know, like the norm. The deal is, and they're doing it. I like using this. teachers are taking the tests. They're gonna do, that's what I was saying, I was like, how much kids don't even know what to
We had a 2D shape, like it's a tetra shape.
I would agree from what I've seen, what you've taught
You have to figure out how it moves.
Right, yeah, they know your holidays, yes. I mean, so, yeah, like, it's so different now, like, in my school, they have science, biology, they just need 2 sciences, they don't need more, like, before they were required by Really? Yeah, they've done it. I know, I'm like, right here, I don't know if I would something.
Displacement is, as in use science, in the science way, is not in the national standards. The word displacement is in there, but it means one process or being displaced by another. It's a generic English usage, not science. Thank you.
We get to fix that when they come to college?
Yeah.
Is it not me, because I'm not my problem. No, one thing I wanted to stress that's in my head as a physics person is to remember that the point of reference, I always pretend is not moving. That way I can compare motion to it. And even though she's on a bicycle and she's moving her along the ground, if I pretend she's stationary, like you say, the distance between me and her is not changing.
So, based on what you just said, I'm thinking if she is the point of reference, she's not moving. If you say that she is moving, then your point of reference has changed because she's.
Yes.
Because-
Your friend is at the park watching you. If you use your friend as a point of reference, are you?
When we were teaching the physics year, we spent probably 3 hours, 3.5 hours on position. And those teachers were complaining about it and fussing about it, and then the next day we came back and we moved on, as you can see, to frame of reference, point of reference. And they kept using the vocabulary, they kept using the ideas of what is position, etc. And as you might guess, I said, okay, now who was complaining about learning this yesterday? Look what you're using, look what a foundation you have for it. Do you know where position is in the TEKS?
In science, maybe? Probably.
Okay, fine, it's not.
Kindergarten. Oh, yeah, we talked about.
Kindergarten, it starts in kindergarten. So if a kindergarten teacher does not understand the importance of position, and I know there's some changes, Ashley, in position and frame of reference, because I glanced at it in the new TEKS, and I haven't researched it yet. But, you know, if that is given a low level of importance in the kindergarten teachers' minds, they're not ready for physics at high school level.
I think the understanding is, and from also my experience dealing with the lower grade levels teachers, in kindergarten, it's I'm here, you're there, you're in front of me, you're behind me, you're to the left of me, you're to the right of me, descriptions. And, well, everybody knows that, so we're just gotta, you know, I
Everybody
know.
knows that.
Yeah.
Right.
That's what they think.
So it doesn't, the teachers don't, they don't know or understand the importance of in relation to the what? Well, they don't get into the whole point of reference. It's like, okay, I'm above, I'm below, I'm around,
They're always the point
done.
of.
So in the TEKS then, where's point of reference? I don't know. We'll find out though. Sorry, carry on.
But just like you were saying, if you had a point of reference that was, I don't know how to phrase this. The point of reference is always considered to not be moving. So if I say you have a stationary or a point of reference in the park, a little kid goes, but the park is moving, because we're on Earth and we go around the sun. So when we refer to it as a point of reference, we're saying we're pretending, regardless of anything else, that that's stationary. And then we can say, are we getting closer to it, farther from it, going along our coordinate system? Our little origin is stationary, and the axes are not rotating out. Oh, anyway, back this way. There's a bus. Notice the little stop sign right there. We'll start to point that out. The boys in the back look worried. Bus is not moving. Okay, where are you that you observe this?
You gonna pull a name?
Where's it look like you, oh yeah, it's like, where's it look like?
Clinton?
I'm guessing that's
That's
where
Rochelle.
you, that you observed this. What does that mean? Where are you that you observed?
Where you
this?
located.
What is this?
It's access for.
What is this? Is this that picture?
I am in this
We
room.
observe the action from the sentence above.
That's what I thought.
The bus is not moving.
So
Or
where are
English,
you
but
that you observe the boys looking worried?
It's that because it's not moving.
Yeah, where are you located? That you
You're asking for a
observe that the
position.
bus is not
It's not
moving.
moving.
It's a poorly worded question. English wise. It's like teaching.
Associated Astoria.
I'm wondering, does this refer to this picture? As if I was a camera, right here. Would I be directly behind the bus to see that?
Why do you need to be behind the bus?
Well, would I be in the same lane as the bus?
You could be behind the bus. And they're not moving if you're going the same speed.
And see that?
I could be getting ready to pass them.
That would be wise to get
You
ready
could
to
be
pass them with the
passing me.
stop sign sticking out.
Yeah, well, it happens all the time.
Don't do it. That's the whole idea I'm getting at is, do we use this as the criteria of where? Or do we use the fact that we could say, the bus is not moving, therefore it's a reference point. And then any other reference point, no, any other point in this coordinate system would work for my location. To see that the bus is not moving. It could be above it, it could be below it. Unless they mean I'm right here. Using the clues of what the bus looks like to tell me where I am. What do you think? You go with that? Anybody? Said, where are you? Well, how the heck do I define where I am? What do I use to help me figure out where I am?
call my name.
What?
I would agree with what she said.
She said the
Point of
bus.
reference, which is the bus.
Point of reference is the bus.
Okay,
My frame of reference.
if we wanted to draw a coordinate system, it's to locate me. Where are you? That is, where am I? Using the bus is not moving. How would I do that? Well, I'm just curious because when we do motion and analysis of motion, oftentimes we view it from a different point of view. Not a different frame of reference, but a different point of view. For instance, imagine I was above, taking a camera, imagine a camera was above. And there's a nice two-dimensional coordinate system underneath here, little, streets or something. And there's a bus. We're looking down on the bus. You say, where's Russell? I've got a point of reference. There's the bus. Where's Russell?
You're in quadrant 2, in comparison to us, we're looking at a coordinate system. Based on what I see from this position,